Example 6, Chapter 15. Consider following reaction which occur in a steady state, steady process. A steady state, a steady flow. CH4 plus 2 oxygen liquid. The reaction and product are each at the total pressure of 110 megapascal and 25 degrees centigrade. Determine the heat transfer per kilomole of fuel entering the combustion chamber. Chamber CH3. For a reactant, the first law can be applied. At first, we should determine the control mass or control volume. In this case, we have control volume, combustion chamber, inlet state, P and T now. State fix, exit state, P and T now. State fix, process, steady state, and model 3 gases, ideal gas. Real liquid water. For the control volume, the first law can be written as this relation. First law, Q control volume, NIH bar I, NEH bar E. Using value from table A10, product reaction, and Ne H bar E for the given reaction, and H bar 0 liquid water. O2 H for the pure substance, the H bar, now we can calculate the required heat transfer. In most instances, however, the substances that comprise the reactant and product in a chemical reaction are not at a temperature of 25 degrees centigrade and a pressure of 1/10 megapascal. Therefore, the change of enthalpy between 25 degrees centigrade and 1/10 megapascal and the given state must be known. For a solid or liquid, this change of enthalpy can usually be found from a table of thermodynamic properties or from a specific heat data. For gases, the change of enthalpy can usually be found by one of the following procedures. Assume ideal gas behavior between 25 degrees centigrade and 1/10 megapascal and the given state. In this case, the enthalpy is function of temperature only and can be found by an equation of the related heat, specific heat, or from the tabulated value of enthalpy as a function of temperature. Table A6 gives an equation for the specific heat for a number of substances, as table A9 gives the A6 can calculate H for P0, and A9 give the values for H bar 0, H bar in the kilojoule on kilomole, in the reference temperature and pressure. The subscript 0 is used for designated that it is the enthalpy of at 1/10 megapascal pressure, based on ideal gas behavior, that is the standard state enthalpy. If a table of thermodynamic properties is available, delta H bar can be found directly from these tables if a real substance behavior reference state is being used, such as that described above for liquid water. If a hypothetical ideal gas reference state is being used, then it is necessary to account for the real substance correction to properties at that state to gain entry to the tables. If the deviation from ideal gas behavior is significant but no table of thermodynamics properties are available, The value of delta H bar can be found from the generalized table or chart, and the values for CP zeros at 0 or delta H bar not in applying the first law to a steady state process involving a chemical reaction and negligible change in the kinetic energy, we can also write this relation. Ni Ne H bar